Alright, so this is section 1.1 in Pre-Calculus 30, and this is the shot of the textbook there, and for you guys that's on page 4. And the first chapter is about function transformations, okay? So functions you've learned before in Pre-Calculus 20, okay? These are graphs, either straight lines, absolute values, sort of like graphs that look like a V maybe, or parabolas, or cubic functions. So you've explored some functions, and we'll explore more functions in Pre-Calculus 30. But what we're going to talk about are function transformations in this chapter. Now, if you think about a transformation, notice in your textbook here, what do we have here? We have like a, well, is that a moth or a butterfly? I'm not really sure. But anyways, there's a transformation that goes to a caterpillar, goes into the cocoon, and comes out a butterfly, right? And so when we have a transformation like this, what we're talking about is what can one graph or one function transform into? Okay. So we're talking about changing shape, changing position, changing orientation, the way it opens up, either up or down, or a positive or negative slope. So how can you take a graph and transform it, basically deform it, think about, to stretch it or to move it so it looks like something else? So this little intro here, it says this: mathematical shapes are found in architecture, bridges, containers, jewelry, games, decorations, art, nature. Designs that are repeated, they are reflected, they are stretched, they are transformed in some way, and are pleasing to the eye and capture our imagination. So that's what we're going to talk about. Now in this picture, it might be tough to tell, but obviously we have a repeated pattern of glass here. Right? And even look at this right here, like I'm highlighting with my mouse on the right. You see, that's sort of a parallelogram there, right? But if you think about this sheet of glass right here on this building is probably identical to this sheet of glass. Yet from our perspective, it seems squished up a little bit. It seems to be sort of tilted, angled. You see, it seems to be compressed a bit. Well, this would be like a transformation from this pane of glass on the right turning into this one, or even into this one. You see, those are transformations. They've been stretched, moved, disoriented, different things like that. And so just like we have mathematical expressions for lines and parabolas and different things, we can alter those expressions to form transformations. So after that little intro there, section 1.1 is all about horizontal and vertical translations. Now, a translation is a type of transformation, all right? And if you translate something, okay, we have some international students here, a translation, right, is moving from one language to another, right? We're translating some text. So in math, when we talk about a translation, it's literally moving. Translations are moving. They're sliding left, right, or up, down. And here's horizontal and vertical translation. So let's go back to our notes here. Okay, so I would suggest that you write down translations, and I would suggest that somewhere beside translations, we are going to be talking about moving a graph. Okay? Moving. As opposed to stretching or compressing. Okay? We're not altering the shape, we're just moving the graph. And how are we moving it? Well, we're going to see how we can move the graph left or right. And we're also going to see how we can move the graph up or down. And we're going to find out about how the equation, okay, changes this by, transforming the equation of lines or parabolas. Okay, so we're going to talk about algebraically how can we do that. Okay, so if you look in your textbook now, page 6 or so. In your textbook, we talked about this. Do you guys remember? Okay, let's see if you remember this. What form of a line is this right here? Do you remember what form of a line this is? It's, okay, you see M is what? Slope, and we have a x1, y1, that refers to a? Not intercept, it's point slope form. Okay, point slope form. Check out the popular video on YouTube, Mr. MathWell, point slope form. You will be inspired. Okay. Anyways, point slope form. Okay. Now, if we alter the slope, we're going to get a different line. If we change the point, we're going to get a different line. But what about, let's see. Okay, so in your textbook there, instead of writing it quite like this, they write it a little different way. So I just want to highlight this here. They write this, y minus k. So it's kind of the same. But instead of a slope here, so this is a linear function, right? Instead of a slope here, what they're doing is they're saying, you know what, I'm going to take some other function. It doesn't have to be a line. It could be a parabola or whatever. And inside here, here's the x, like f of x. But I'm going to add a parameter here. So it's kind of similar, but not the same. Not the same, okay? So this is, now what is this? I'm going to say that this is basically the formula for translation, or for translating any function. And that any function will be f. Okay? Now where does this come from? Well, if you consider this right here, just what I've highlighted, that is y equals f of x, right? And we know that f of x is function notation for any kind of graph, a line or parabola or whatever. And so just like over here, now look at back up over here now, all right? So we said this is kind of a similar sort of form. Notice that we could have, this comes from this, y equals mx. This is a straight line, right? This is a straight line that has the point at the origin, basically, goes through the origin. These are basically like parameters. This is another point other than the origin, and it kind of, what it does is it moves that graph left, right, up, down. Okay, so just like these two are connected, this is connected. And I can now view this as any function, and I can change the parameters. All right, so enough of that. What we're going to do now is we're going to get on the graphing calculator, and I'm going to graph some things, and I'm going to hand out some calculators for you, and we're going to do this together. Okay? All right, so what we're going to do is we're going to graph y equals 2x. Now, on your graphing calculator, you have the y here, and it just asks you to plug in the rest. So obviously there's 2 there, and here's the x button right here, guys. It's x, comma t, comma theta, comma n. So your variable button is right here, okay? The input variable button right here. So if you do this and you hit graph, your graph should show up and look something like this. If you don't have the axes quite right, you can go zoom 6 to give a standard window. 10 this way, 10 up, 10 back, 10 up. Okay? So that looks like that. Now let's zoom in, okay? So zoom 2, enter, and you'll get a little bit of a different piece there. Okay, so it's zoomed in a bit. We can see 0, 1, 2, and so on. Now what we're going to do, guys, is we're going to go back to y equals, and I am going to adjust, okay, I'm going to adjust a parameter here. And you know what we're going to do? And we're just going to add 1, okay? 2x plus 1. And let's see, what do you guys think is going to happen? You guys know what y equals mx plus b is, right? What's going to happen? Up, yes. The whole line is going to move up 1 unit, or at least it should. So let's see what happens. Hey, good job. So it was going through the origin, but now it's moved up 1, okay? So that is a vertical translation, all right? Now you may say, hey, Mr. Maxwell, I thought, isn't that this x value right here? Well, actually, it's not. Let me show you what's happened here. Okay? So if we have y minus y1 equals m times x minus x1, what I've done is I've set the x1 to 0. So I've got y minus y1 equals mx. And this plus 1 that I put over here, okay, this one right here, is actually the y value, you see? So that's actually y equals mx, and this over here represents the y, or the vertical translation over here. Okay, so that's what we just did. If we wanted to move this line to the left or to the right, which is going to be a bit tricky to see because it's a line. It's tough to know when it moves up and down or left half, right? Something like that. But if I wanted to move this over 1 unit, anyone have an idea of what I might need to do looking at this, at this format over here? Take a look at this right here especially. So remember, this is vertical, up, down. This, x, is horizontal. So if we go back to here, what I'm going to do is I'm going to insert a bracket, all right, and I'm going to go, let's say let's say -1 with the bracket. Okay, and let's see what happens here, -1. Oh, okay, so first of all, this is not a vertical translation of 1 unit in any direction. But what it is it translated to the right 1 unit. Okay? So what that means is that inside the brackets with the x, that is the horizontal movement. What you need to notice here, and in both this form and this form, is that this is x minus this h value. And so why did the graph move to the right 1 unit? Because what I actually did was I subtracted a +1. Okay? So inside the brackets, the horizontal translation will be represented by this number of units, whatever this is over here, and really the direction that would be opposite of what this sign would be. Okay? So why don't we just take a moment and just kind of write that out, okay? So if we look at the definition of a translation, it's a slide or a movement that results in a shift of the graph without changing the shape, okay? Or its direction of opening, okay? Or it's not twisting it. It's just a slide. It's either a left, right, or an up, down. Now this is where it gets important here, okay? The vertical and horizontal translations are types of transformations that are basically affected by a change in the equation. And so this is the one right here that we just talked about. Okay? We had a straight line, so I just had my m slope there. And here I had a number here which moved it to the right. So because this is of the form x minus h, an x minus 1 moved it actually to the right 1 unit. So this is what happened. Okay, so oh wow. So this is what happened. Here's the graph. Okay, and this is y equals 2x. And this graph over here, the next one that we drew, sorry for the axes here a little off. This was the next one. Okay, went through y equals 1. And this was y equals 2 times x minus 1. And that represented a horizontal translation of 1 unit to the right. What that means is, again, if this sign is negative inside the brackets there, then you go to the right. Right? Goes to the right. And if it's positive, you go to the left. So it's kind of like it's opposite. It feels wrong, right? When it's positive, like +1, you go left. That's a bit counterintuitive, but that's the way it is. Now, the other thing that we did, remember the other thing that we did was we did y equals, what did I do? 2x plus 1. There. I did 2x plus 1. And what that actually is, remember, that's this. Y minus 1 equals 2x. So that's where you get this k value. Okay, this plus 1 is actually the k value because the format is y minus k. Now, you'll see it written like this sometimes, but more often or not, you'll see it written like this because that's y equals mx plus b4. Okay, so vertical translations, horizontal translations are affected by these parameters, and they call them h and k. H, you can think horizontal. K, well, it's not horizontal. But anyways, I don't know what you think of for k. It's h and k. All right? And so if you want to apply both transformations to a graph at the same time, this is what it looks like, and I will rewrite this. Y minus k equals f times x minus h. And so again, here is your vertical component. Here is your horizontal component. So up, down, side to side. So something else I want you to explore here. I want you to get your calculators, put in y equals x for the first one. And on the second line, what I'd like you to do is I'd like you to do absolute value, okay, it's right here. So again, go to math, and then go to the right over to number there. And this number 1 is ABS, that's absolute. So that means absolute value of x, okay? So if we graph them, okay, there's your first one, and here's your second one. Now it doesn't stop here, it actually continues on the exact same graph here, okay? Now let me just explain absolute value, because absolute value is not something you spent probably a lot of time on in class before, and it's a real sticky point for a lot of students. So again, if I just draw this real quick, here is the graph of y equals x, okay? Now absolute value, what you know about absolute value is that if a value is positive, the absolute value is the same value. It's just the positive value is, right? If a value is negative, the absolute value is, the negative sign is dropped. Absolute value function, if we have y equals absolute value of x, like this, what that means is all the positive stuff, okay, let's do it in green, all the positive stuff is the same, right, because that doesn't change, but all the negative stuff becomes positive. So that's why you have this part. Anything that's negative, if this is negative 1, becomes positive 1. Negative 3 becomes positive 3, and so on. So that's why you get this sort of little V shape, okay? You get this little V shape. Absolute value is used because it's easy to kind of see, as opposed to the line, it's easy to see where these transformations lie. So let's do x, minus 2 and plus 1. Okay? So what that is, before we graph that, that's going to be y equals absolute value of x minus 2 and then plus 1. So that's what it's going to look like. So what is this number going to do to the graph? It's going to shift it which way? Left to right or up and down? This number. Left or right? Yes, it's going to go left or right. That's the horizontal part. Now, it's minus. It's positive x minus 2. So which way is it going to go? To the right. And how many units will this graph shift to the right? 2. Yeah. Okay, you're getting it. So this graph right here, we know is going to go 2 units over. So it's going to kind of look like this. That's what that does. What does this part do? What does that part do? That moves the graph up, down, and you are absolutely right that when it's on this side of the equation, this sign means up, and this is how many units. When it's on this side of the equation, that means up. Okay? All right, so you're right. This is going to, so now the final graph is going to be like this, or it should be like this. 2 units over, 1 unit up. So let's just see. Got that in there. Let's graph it, and look at that. 2 units over, 1 unit up. You see that? Okay. So you can take a graph, and you can alter its position by changing the parameters. And these are the first 2 parameters that we're looking at, the h and k. Any questions so far? Okay, does this work for a parabola? That's my question to you. And yes, it does. But a parabola might look like this, right? Y equals x squared. Let's graph that quickly. Okay, let's clear this one away. Y equals x squared. So if we graph that, that's your parabola. That's what it looks like. Okay? Now, here's my challenge to you. I want you to move this graph, okay, So this is roughly what it looks like right here. Oh goodness, you know what I'm saying? Okay, goes through the origin, right? I want you to move it down here, where this point right here is -3, -2. I want that to be the new vertex. Okay, same shape, but I want it moved over to the left and down. So go ahead, take 30 seconds, and see if you can do that on your own. Okay, so that's the kind of parabola I'm looking for. That's 3 to the left and 2 down. Anybody get it? Right? Yeah? Couple? Anybody else? Oh, you, Landon? Okay. All right, so let's check it out here. Did you have something that looked like this? Okay. All right, that's a tricky one. I threw that parabola in there because remember the parabola is x squared, and what you have to do is to move it horizontally, you have to have that h parameter inside the brackets with the x. Okay, that's what's important. It's going to be inside brackets with x, and this is going to be now moving. That's plus, so it's going to be to the left, 3 units, and so this was just old x squared. Now it's x plus 3 squared. And then 2 units down on this side of the equation is a -2. Okay? That's really good, guys. That's really good. Now, the only other thing that I need to teach you about here is mapping. So I'm going to take a few minutes just to talk about mapping. Now, if, let's say we had this parabola and the x and y here were 0, 0, and that was the vertex, okay, of the parabola, and every point that's on this parabola went to the left 3 and down 2. There's a type of mapping that you could give here. So this is xy is 0, 0, and it goes to -3, -2. So how we can write that? Just plain old xy means that the x values are moved 0 from their original position, and the y values are moved 0. If I wanted to say I need to move the x values to the left 3, that's all the x values from this graph to the left 3 units, right? That would look like this. X minus 3. So all of the x values would be -3 for our new translated graph. And if I wanted to say all the y values had to go down by 2 units, that's all of these down by 2 units now, then I would say y minus 2. And that would be, what does it say in the book? It's just called the mapping notation, I guess. And for you guys, that's, I guess, on page 7. Okay? So it means every point from the original graph, whatever the x and y values are for any point on the graph, the x value would be moved to the left 3, and the y value would be moved down 2 to get your new translated point. Or this is called, this represents the image point. Okay, in the mapping notation, image point. Okay, so you'll run into mapping notation there, and that's basically what they mean. So horizontal translations are always x, okay, x plus h and y, and vertical translations are always x and y plus k. Okay, so that's the horizontal, and this is the vertical. Okay, so there's the assignment for 1.1, and another thing that I want to point out to you guys here too is that in this textbook, the really nice thing about this textbook is that they have key ideas, a bit of a summary at the end of each section. So please spend some time reviewing this. This is a little bit of, the summary of the high points from the lesson. My notes maybe not look exactly like this, but this is good for you to read over and to refer back to while you're doing your assignment. So there's the key ideas that you can read about. That's what we tried to accomplish in this lesson today.